Welcome to our continuing coverage here at HP Discover. I'm Andy McCaskey from SDR News, and we're going to be talking with folks from Intel and from HP. Dylan Larson from Intel on the far end here, and Jim Gantier, who's the Vice President of Enterprise Group here at Hewlett-Packard. And maybe we could start out with Jim. As far as what are you seeing as far as general trends at the data center level?
Okay, so in the data center, we're seeing what we refer to as things driven by megatrends. Megatrends being items like social, mobile, cloud, big data, and security. But all of those are driving a requirement for increased performance, increased space, and in some cases, trying to do all of that in a much reduced footprint. So one of the things we share with Intel is that if you look at the extrapolation of how much performance to solve some of the world's biggest issues will be required, that present course and speed is unsustainable, and that's why you see a lot of innovations coming from a combination of HP and Intel, because we want to go help change that curve and do today what we can potentially pull off to accelerate the world of tomorrow.
Well, does this come from the difficulty moving to smaller and smaller geometries at the chip level, that at a certain point you're going to hit a limit with the process, what the process can sustain?
I don't know. I mean, the process generation is always one of those key elements that helps us deliver on that promise, right? And we have lots of choices we can make. We can deliver more cores for higher throughput. We can deliver higher frequencies. The point I think that we're finding is that the demand for compute is insatiable. So there's no slowdown in the amount of computational requirement that we're seeing. The challenge is, how do you deliver the right optimal infrastructure to get there? Mm-hmm. And some of that comes down to the thermal trade-offs. It comes down to the ability for software to scale to these kinds of multiple core environments for throughput machines, or the elements of what you do to balance the platform between memory, I/O, and other performance. And we look at all those sort of attributes and how we'd optimize the chip design to support those.
Yeah. So Jim, you've got a lot of opportunities to excel. How do you choose? How do you choose where to put the investment and the intellectual power to continue to develop ways to take advantage of what Intel's providing?
Our answer is very simple. It starts and ends with our customers. The beauty of what we do for a living is we wake up every morning thinking about our customers' biggest issues. And right now, as Dylan mentioned, performance happens to be one of them. I'll give you just a quick extrapolation. And by the way, that performance requirement varies depending on the market segment you're in, whether you're doing core computing, whether you're doing high performance computing, whether you're doing mission critical, or whether you're doing virtualization in cloud. I'll give you a very simple example. High performance computing. The team and I were doing a couple of back of the envelope calculations, right? And we said if we were to take all of the supercomputing platforms that came before, and what we wanted to do is extrapolate that out into the next 4 or 5 years, we would need almost like a petaflop of compute capability within each of those platforms. To power and cool that, because if you've got that level of performance, as Dylan mentioned, you've got to also be able to effectively cool and power that system. It would take a gigawatt of power. Just to put that in perspective, a gigawatt of power is the output of the Hoover Dam. Oh, and by the way, you'd also have to have roughly 30 football fields in order to house that incremental compute. So, as I mentioned before, the present course that we were on was unsustainable. Mm-hmm. So what we've done, and I'll use an example that both of us are celebrating here today, is the announcement of the Apollo 8000 system. And with the Apollo 8000 system, I'm also going to tie that back to segments, we're going to redefine the way people look at high performance computing. A lot of folks don't realize that within the high performance computing space, we have about 40% of the top 500 supercomputers on the planet.
Wow.
Correct, yes, 196 or 198, depending on how you want to measure. But the other fun part is that if you look at the needs of those folks, and one of the nice things about our job is we get to work with some really cool innovators. The one that we're showing here is the National Renewable Energy Lab, which is a subset of the Department of Energy. And what we were able to do for them was threefold. Not only were we able to build them a system that has a tremendous amount of performance, petaflop capability, but the fun part is that we were also to take some of our thermal and mechanical innovations and do it in a unique way. As a matter of fact, that system is water cooled.
Let me bring up this camera, which we thoughtlessly removed here a few minutes ago, because you've got a show and tell.
I'll do one better. There's a perfect example. Okay. There's a perfect example of, you know, a lot of the solutions out there, they'll give you performance. But the problem though is the amount of power, the amount of cooling, and the amount of space that would be required to do that is, asymptotic. So what we're able to do, and again, this was in partnership with Intel, is create what we refer to as our dry disconnect technology. So one of the issues with high performance computing is it throws off a lot of heat. And the traditional way to solve that has been to have liquids. There's only one small problem. You probably don't want water and electricity to mix. That's something that Intel and HP agree on. So what we came up with jointly was an innovative way to do that.
Is this the vacuum system?
No, actually it's what we refer to as dry disconnect. And when I say dry disconnect, one of the ways to solve this is, if you look inside our Apollo 8000 system, there's a water wall. There is literally a wall of water that has cold air blowing on it, and what ends up happening is this is attached to that wall of water, so we refer to as a thermal bus bar, and on top of that are cooling coils. There's a very small amount of liquid in here, it's under vacuum, and this would attach to the top of the processor. So the bottom line is that not only were we able to deliver tremendous performance, not only were we able to deliver it in a unique liquid cool scenario, but the beauty is, working with NRail, we're able to save them $1 million worth of OpEx and CapEx costs. Here's another interesting fun fact. This throws off a lot of hot water. Most high performance computing systems do. They were so innovative in the build out of their greenfield data center, the hot water being thrown off of here is what they use to power and cool the building and remove snow from the sidewalks. That's what
a triple threat.
Correct. That's what thinking different is. That's what happens when people wake up thinking about their customers' biggest problems. Dylan, I don't know if you want to add anything to that.
I think one of the things you'll notice when you look at this design is it's small design, right? We're getting to this place where there's a certain class of customers where density is one of the absolute requirements to drive these kinds of insatiable demand for compute. To deliver on that demand, you got to pack a lot of compute into small spaces. Yeah. And that means you got to look at innovative cooling ways, you got to choose the right form factor for the designs that you look at. We talk about the process technology generations and moving to smaller and smaller geometries. Well, that's part of it. Build density, build power, implementations that you got to manage through, and cooling and density is key.
Yeah, and if I can add, if you look at the amount of compute processing power in that rack, because we actually designed that not at, I guess we'll call it typical server or CPU scale, we designed it at rack scale. There's 144 computers in that one rack footprint. To give you another example of the types of things that we're able to drive, not only can we put more in it, but because of the cooling technologies, we're now able to save our customers millions of dollars of OpEx and CapEx every year.
And when you combine that with some of the initiatives that HP Helium and OpenStack have, for a private cloud, you now have vast amounts of power that can be managed locally in the data center for the security of that data that you don't want to leave the premises.
Absolutely, and the other part that's nice is we don't like to think of ourselves as just doing product. We also like to look at what can we do from a program perspective. Right. So in addition to the product that we announced yesterday, we also announced a whole bunch of new services. And one of those services happened to have been HP Helium as a service. So now when people want to take advantage of high performance computing, which traditionally has been the realm of academia and governments, our mission is to actually make high performance computing available to enterprises of all sizes. And the way you do that is either with product or with programs. And so back to your Helium point, folks can now use the Helium service to try and test their high performance computing applications and help develop the innovations of tomorrow by having us as the back end.
And then that also would tie into the challenges of big data with a HANA implementation.
Yeah, which is our CS900 product that we announced, I guess we'll call it earlier last week at Sapphire. That's another perfect example of our strategy of providing what we call a workload optimized platform. You asked the question of how do we decide? We decide by focusing on customers, but there's one precept that we always operate under, and that mission is to provide the right compute for the right workload at the right economics every single time.
Excellent. Dylan, any final comments?
Yeah, I think what you find is though that there clearly is different places that people want to deploy new compute, whether it's big in-memory databases like the SAP HANA concept, or the work around high performance computing, or this cloud elements. And I think one of the things we're looking at is there's much more focus on optimizing the platform architecture and the product lines to actually fulfill the needs of those designs.
Excellent. Where can people go to learn more about the new Apollo computer system and other directions that Intel might be headed in?
Yeah, at Intel.com you'll be able to get a great view. Intel.com/datacenter will help you look at all of the data center specific product lines, my product lines that we drive into the family that we work closely with HP on.
Yeah, and in our particular case, if you actually go to the HP website, right there on the front page, you'll see all the announcements, not only that we're doing at Discover overall, but you can double click on the Apollo family, which is the Apollo 8000 and 6000. And the best part about it is you won't hear it from us, you'll actually hear it from our customers, and you'll hear basically how we're helping them advance the causes, the missions, and the business outcomes they're trying to drive.
I don't know why I keep thinking on the cover of Rolling Stone, but that comes to mind. Thanks very much for joining us.
Thank you.
Thanks to you folks for joining us as well on our coverage here at HP Discover.
Thanks.
Live streaming of SDR news coverage at HP Discover has been made possible by Intel Corporation. Check out Intel OpenPort IT, where you can connect with your peers at Intel on industry topics, best practices, strategies, and more. And by Microsoft, where HP and Microsoft are working together, combining their respective strengths to deliver innovative technologies to help advance your business.